Welcome to this explainer. Today, we're taking basic, stateless AI and totally transforming it. We're going to build an adaptive, context-aware system by stacking its memory layer by layer. If you've ever wanted to pull your hair out because a chatbot forgot everything you said just 5 minutes ago, well, you are in exactly the right place.
Let's be real for a second and start with a highly relatable problem. Picture this. Having an agent that forgets everything between conversations is literally like having a coworker with amnesia. Seriously. An AI without memory forces you to re-explain your preferences, the project context, your entire goal every single morning. It takes what's supposed to be a brilliant, intelligent assistant and turns it into a high-maintenance tool that makes the exact same mistakes over and over. Memory is that magic ingredient. It's the key to turning a basic tool calling loop into a persistent, intelligent coworker.
So to fix this, we're going to build the ultimate agent from the ground up, basically using human cognition as our cheat sheet. We'll hit 5 key areas today. First, the core AI amnesia problem. Second, short-term agent context. Third, long-term learning and facts. Fourth, cross-agent memory sharing. And lastly, procedural memory and common pitfalls.
Okay, kicking things off with Section 1, the AI amnesia problem and moving beyond stateless LLMs.
Here's the absolute root of the issue. Every single time you ping a large language model, it is completely stateless. It only knows what's sitting right there in its immediate prompt, nothing more. So, how do researchers solve this? They use a structured taxonomy that maps short-term and long-term storage directly to how human memory works. Just like you and me, agents need a short-term buffer for recent chats, a scratch pad for whatever task they're doing right now, episodic memory to recall past experiences, semantic memory to hold on to facts, and procedural memory for learned behaviors. Let's just hope the AI gets better at remembering where it put its keys than we are, right? Let's break these down.
Moving right along to Section 2, short-term agent context, buffers and scratch pads.
All right, so how do we manage the AI's immediate workspace, its desk space, so to speak? The most basic form of memory is the conversation buffer, basically just your chat history. But if you just keep everything forever, you are going to slam right into your token limit. Or worse, the LLM starts getting confused as the context window fills up with useless older messages. Because of that, conversation buffers have to evolve. You start with the naive approach of keeping everything. Then maybe you upgrade to a sliding window that drops old messages. A step above that is a summary buffer which compresses older context so you keep the facts but lose the bloat. But for a real, rock-solid production environment, you want token-aware trimming. This perfectly maximizes your context limits without ever overflowing them.
Now, a smart agent needs way more than just a chat log. It needs what we call a working scratch pad. This is a structured state that quietly accumulates intermediate results across tool calls, all within a single task. Think about an agent doing research for you. It needs to keep a running tally of which documents it's already looked at, their relevance scores, maybe how many times a search failed and had to be retried. This working memory persists across the workflow, making sure the AI doesn't lose its train of thought between steps.
The absolutely crucial takeaway here is separation. You have to separate what the user says from the AI's internal working notes. A super common mistake is cramming all that structured intermediate data right into the main message list. No, you do not want to pollute the LLM's conversational context with background bookkeeping. Keep the message list strictly for user questions, tool results the user actually needs to see, and the dialogue history. Use the scratchpad entirely for those behind-the-scenes working notes, source tracking, and relevance grades.
So, that covers the immediate workflow. Buffers and scratch pads are amazing for a single session, but the second you close that thread, they're wiped clean. Which leads us to the big question. How does our system actually remember us tomorrow?
That brings us to Section 3, long-term learning and facts, episodic and semantic memory. This is where things get really cool. We're moving from a single session to true cross-session persistence. Episodic memory is basically the AI's personal diary of past experiences. The way this works under the hood is by extracting 3 things: the situation, the approach it took, and the final outcome of past interactions. All that gets dropped into a vector store. Later on, when the agent runs into a similar request, it uses semantic search to pull up that specific past episode. It's wildly powerful because it injects those past experiences right into the prompt as few-shot context. The result? The agent actually stops making the same mistakes twice, and you can extract these memories dynamically while chatting or just run it in the background to keep things snappy.
Now, while episodic memory is all about specific experiences, semantic memory is about the actual concrete facts the agent learns,
like domain knowledge or specific details about you. Here, you have a strategic choice to make about how you store those facts. You could use profiles, which are single, structured documents for each user. For example, if you say, I'm an engineer on Tuesday, and then I prefer bullet points on Thursday, a profile continuously patches itself to merge those facts together. On the flip side, you can use collections. This is an unbounded, massive set of diverse facts that continuously piles up and is retrieved later via semantic search.
All right, Section 4, cross-agent memory sharing, or what I like to call the collective mind.
Let's zoom out a bit. What happens when you have a whole team of specialized agents that need to work together? Well, without shared memory, every single agent operates in total isolation. It's incredibly inefficient. But if you use a system like LangGraph Space Store, specialized agents can pool their individual insights into a shared, cross-thread memory. Just think about the implications of that. If your retrieval agent figures out a certain database is outdated, or your analyzer agent learns you are super strict about cost savings, a shared base store means the synthesizer agent instantly knows that too. The whole system learns as one cohesive unit. Of course, you can't just have a free-for-all. To keep this collective mind organized and secure, developers use strict memory namespacing. This dictates exactly who sees what. You might set up a user profile namespace that all your agents can see, but obviously only for that one specific user. Or you might have an observations namespace that is completely restricted to just one specific agent interacting with one specific user. Nailing these access patterns is absolutely make or break for a secure, functioning system.
Finally, Section 5, procedural memory and pitfalls, how we evolve behavior while ensuring stability.
We've reached the highest, most advanced level of cognitive architecture, procedural memory. You don't see this one as often, but it is fascinating. This is when an agent literally updates its own core system instructions based on its experience. It allows the agent to self-improve its own prompts. But, and this is a massive warning, you have to be super cautious here. In practice, you absolutely must keep a human in the loop to review and approve these fundamental changes. You really don't want an agent silently rewriting its own behavioral rules behind your back.
Now, as you build out all these layers, there are some huge pitfalls you've got to watch out for. We already touched on the danger of shoving internal scratch pads into the chat log. Don't do that. Another big one is over-extracting irrelevant memories. If you save every tiny detail, you just flood your prompt with low-precision garbage. And from an infrastructure side, never, ever use an in-memory store in a production environment. It's a disaster waiting to happen. The second that server restarts, poof, all of your agent's hard-earned cross-thread memories are completely gone forever.
So, let's bring it all together. By systematically layering these 4 core memory types, conversation buffers for immediate dialogue, working scratch pads for the active task state, episodic memory for past experiences, and semantic memory for concrete facts, and tying it all together with shared namespaces, you completely change the game. You transform a fragile, forgetful script into a persistent, intelligent coworker.
You've got the architectural blueprint right here. You know exactly how to build an AI that actually learns, adapts, and remembers over time. All the concepts are mapped out, so the only question I have left for you is, are you going to keep building amnesic chatbots, or are you ready to engineer a truly adaptive agent? Thanks so much for hanging out with me for this explainer, and I will catch you on the next one.